In this video, I'm going to show you how to calculate a determinant in the general case for a n times n matrix, so any size of matrix. The method I'm going to teach you is called the Laplace expansion, and it's usually a method that is used to teach students, although in practice, computers don't calculate the determinants using this method because it becomes too long. But for small matrices like 2 by 2, 3 by 3, 4 by 4, it can be very good, very efficient for students to learn about determinants. So let's go ahead with it. So a general n times n matrix, and we are going to learn about the method for calculating the determinant called the Laplace expansion. To explain this method, I'm going to use an example, and this example is going to be this 3 by 3 matrix that you have here, where I labeled every element with the subindices A, I, J, where I is the row and J is the column. Yeah? So that's the usual way to label the elements of a matrix. So to explain the Laplace expansion method, we need to explain what is a matrix called the matrix of minors associated to the matrix A. Okay, so we start with matrix A, and now we calculate a matrix called matrix M, the matrix of minors. And this matrix M has the same number of components as matrix A. And each of the elements is given by a determinant of a smaller matrix. So let me write it explicitly here. So the element Mij is equal to the determinant of the smaller matrix that results when starting with matrix A we remove the ith row and jth column. Okay, let me give this as an example. So for example, M12 would be equal to a determinant of a smaller matrix. How do we get this smaller matrix? So we select the 1, 2 element of matrix A, yes, and now we remove that row and that column, and we are left with only 4 elements. So these 4 elements form a 2 by 2 matrix. Okay, and the straight lines here mean calculate the determinant of this 2 by 2 matrix. Another example, M23. So M23 would be calculated by looking at the element 2, 3 in matrix A, removing the corresponding row and the corresponding column, and we are left with only 4 elements. Yeah? And those 4 elements, we calculate the determinant of that matrix, and that would be A11, A12, A31, A32, right? Because those are the 4 elements that, let's say, survive when you remove the green row and the green column. Yeah. So in this way, we could calculate each of these minors. Yeah, here I gave you an example of how to calculate 2 of them, but you can calculate the 9 minors. Or in general, if it's a n by n matrix, you can calculate all the minors, which in total are n squared minors. Yeah. So that's how to calculate the matrix of the minors. Now there's another matrix called the matrix of the cofactors. So let me define this. The matrix of the cofactors, let's call it C, is equal to a 3 by 3 matrix and it is almost identical to the matrix of the minors, but changing the sign of some of them in this way. Okay, so we use like a chessboard pattern of plus and minus signs. Yes, so once you calculate the matrix of the minors, you just change the sign of some of the elements, and that gives you the matrix of the cofactors. We can write this more formally if we use this notation, that the element Cij is equal to minus 1 to the power I plus j, which gives us the chessboard pattern of signs, times mij. Okay? So that will be the matrix of the cofactors. And let me write this explicitly. This is a chessboard pattern. Yes? Okay. Next step. Once you know how to calculate the cofactors, you are ready to calculate the determinant of a matrix. So, the determinant, you can follow these simple 2 steps. 1. Calculate minors and cofactors for any row or column. Any row or column. So you choose. Okay, so you have your matrix and you say, okay, let's choose this row. And you calculate all the minors corresponding to that row and all the cofactors, which is just the minors but changing the sign of some of them. And then step 2, you sum the products of the elements of that row or column with each corresponding cofactor. So let me write that down. So let me give you an example, because without an example, this is very difficult to understand. Let's say we have our matrix A, which is a 3 by 3 matrix, and you choose the second row. Okay, so the second row is A21, A22, A23. Yeah. So we ignore the other entries, which are here. We choose this second row. Okay. So the first thing you would do is you calculate the minors and the cofactors corresponding to that row. Yeah. And then the determinant of A is equal to the product of the elements on that row with the corresponding cofactor and adding them up. So it would be equal to A21 times the cofactor 21 plus A22 times the cofactor 22 plus A23 times the cofactor 23. Okay? Now let's say that instead of choosing that second row, you chose the third column. Okay, so you chose this, the third column. So the elements of the third column are A13, A23, and A33. So then you would calculate the 3 cofactors corresponding to that column, and then you could calculate the determinant of A as the sum of the products of the corresponding elements with the corresponding cofactors. So A13 cofactor 13 plus A23 cofactor 23 plus A33 cofactor 33. And that will also give you the determinant. So whichever row and whichever column you choose, the answer is always going to be the same when you do this operation, and that's going to be the determinant of the matrix. Okay? So in the next video, I can show you an example.